Alright, here's a video of how to calculate the grams of solute that you would need to change the freezing point. Alright, so the first thing that I would start with before you even begin the problem is write down the formula that you're going to use. So it's the change in temperature freezing equals I KF M. Alright, now the thing is, to figure out grams, you have to figure out where is grams located at in this formula. And the thing is, if you can figure out the molality, which is little m, you can get the grams from molality. So what we're going to do is we're going to plug in the numbers that we have, and we're going to try to solve for molality first. Okay? So we want to change the temperature. We want to change it to 3.8, negative 3.8. So that means, remember that the water's freezing point is 0, so the change in temperature is going to be a positive 3.8. All right, we're going to have to get the Vant Hoff factor, so we'll have to write the dissociation equation for calcium chloride. So it's going to break into 1 mole of calcium ion and 2 moles of chlorine, so 1 plus 2 is 3, so I is equal to 3, so that's going to go right here. You'd have to look up the freezing point depression constant for water. That's 1.86 degrees Celsius over little m. Now, what we're not going to know at the beginning is little m. Alright, and so what we're going to do is we're going to solve for what little m is. So we're going to divide both sides by 3 times 1.86. We're going to divide this side by 3 times 1.86. So remember, on your calculator, you're going to take 3.8, divide by 3, divide by 1.86. And so what would happen if you did that math? You would get that the molality, or little m, is equal to 0.68. That's what that's going to equal. Now what you can do is you can remember the molality formula, that molality equals moles over kilograms. So if you can plug in the numbers and get moles, then you can change moles to grams. So what I'm going to do is I'm going to write that the molality is 0.68. That's going to be equal to the moles that we don't know divided by the kilograms. Well, we got to come back up here to see how much water we're using, and so we're going to move the decimal 1, 2, 3 spots, and so that's going to be 1.7 kilograms. And if we do the math, we're just going to cross multiply. We've done that before. We'll get that the moles is going to equal 1.2 moles calcium chloride. All right, so now all we got to do is change the moles to grams, and we'll have our answer. So 1.2 moles calcium chloride. We're going to look up the molar mass and find that 1 mole of calcium chloride is equal to 111 grams calcium chloride if you round it off a little bit. And so 1.2 times 111 divided by 1. Okay, that's going to equal, let's see here, about 129 grams of calcium chloride. All right, let's review. Step 1, write down the formula. Okay, step 2, substitute in your change in temperature, which is 3.8 in this case. Okay, find the I, the Van Hoff factor, writing the dissociation equation. Okay, that's number 2. Okay, 3, you need to plug in the freezing point depression constant. So plug that in right here. Okay, the 4th thing you want to do is solve for little m. Once you get little m, plug that into the molality equation along with your kilograms of solvent and solve for moles. Once you get the moles, change moles to grams. And that's how you do a problem like that.